Okay, so here's what we're going to work on now is conditional probability. And we kind of did this at the beginning of the unit, but we did it by actually writing down all of the different outcomes and kind of just counting to find it. So right now we're going to try and do conditional probability, but using a tree. Okay, so I picked this one because when I was little, my grandma used to play this game called Pinochle with her girlfriends. And so when I was writing some problems, I thought I would investigate that a little bit. Okay, and it says that you have 3 packs in a drawer, 2 are regular, and the third is a Pinochle deck. And so the probability if you grabbed a card out of 3 that you got a regular deck, there were 2 decks and you grabbed from 3. Okay. Let's see how you did your tree, but first kind of let's make the tree, then we have to think about the cards. Okay, so the first thing you would do is you would grab a deck, and there's really 2 outcomes. You could grab a regular deck, or you could grab a Pinochle deck. And there were 2 regular decks to be picked, and there was 1 Pinochle deck. And then the next thing you're going to do is grab a random card. And the attributes we care about are they numbered cards or do they not have numbers? And so it's the same attribute for the Pinochle deck. Okay, so let's kind of think about this. I'm going to get a different color pen. Let's make sure we can get the chance of getting a number deck. Okay, so if you're in a regular deck, you've got the numbers 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that is 9 cards, and the ones that don't have numbers on it are ace, and then the 3 face cards, jack, queen, king. So it's 9 out of 13 for each suit, so we may as well use 9 out of 13 instead of timesing it by 4. That's 9 out of 13. Which means the chances we don't get a numbered card are 4 out of 13. Okay, let's do the same thing with the Pinochle deck. We'll grab a different color. Let's do orange. Okay, so let's do the Pinochle deck. So either you looked at the picture or you're looking at the words. So with each suit, there's a 9 and a 10. And they have doubles of those. So with each suit, there are 4 cards out of 12, which is 1/3. And if you want to check to see if you're right, let's do the no numbered cards. So you've got all the other ones. You got the ace, the king, the queen, the jack, and those are 4. So 4 times 2, which is 8 out of 12. Okay, so we double check, so that's good. So the number chance of getting that's 2/3. So the chance of getting a numbered card is pretty low. It's 1/3. But the chance of not getting numbered is pretty high, 2/3. Okay, so let's kind of go down and let's get all the probabilities. I did mine already, so if you want to pause the tape and get yours, you can go do yours. I'm just going to write them. So remember, we're multiplying down this number times this number. And I'm just going to write them all in fractions. Okay. And so what was our task? Our task was to find the probability we drew a numbered card. So here's all my outcomes. Let's see. This is a numbered card chance, and this is a numbered card chance. Since there are these 2 distinct paths, we are going to add those to get the total probability. So it's 18 over 39 plus 1/9. You guys check that I added right when I typed. I got 67 over 117. I'm going to divide to get me a percentage. So it's about 57%. Okay, so we've done that already. So now let's move on to today's big idea. Imagine your friend had the same situation, but you didn't see what they grabbed from the drawer, but they told you they drew a numbered card. What's the chances that they grabbed a regular deck? Well, if we didn't have any other information, we would think that would be 2/3. But we've got some other information. We know we got a numbered card, and most of the numbered cards came from the regular deck. So my guess is that this is going to be higher. That this should be higher than 2/3, because most of the numbered cards did come from a regular deck.